and as you know, he currently joined eYantra. Also, he's an assistant professor at IIT Bombay. So his key research interest is mostly related to mobile navigation, localization, and as Sir said, he's core robotics guy. Yeah. So next, Professor Paritosh Pandya. So he's an adjunct professor at IIT Bombay. His research interests are mostly related to logics, automata, concurrency. He did his MTech degree at computer science at IIT Kanpur and PhD in computer science at Bombay University or TIFR. Let's give him a round of applause. Yeah. And next, last but not the least, Mr. Muthu Mangalyapan. So he's a proud alumnus of eYantra. Like Kavi sir usually tells us that you should be doing entrepreneurship. He's the best example and best alumnus. So he's a CEO and co-founder of at Goat Robotics. He's also co-founder at Catamaran Technologies. As I said, he was an intern in eYantra. He also went through this process. And then he did his MTech from BITS Pilani and bachelor's from PhD Technologies. Let's give him a round of applause. Sorry for the disturbance. So let's start the presentation. Like we will explaining you about. So we will be explaining you about the Holo Battalion, what exactly the themes, what all challenges, and what is the rules and all stuff. Cool. So I will hand over this to Sai. Yeah.
Okay, so this theme is Holo Battalion. You can see there are multiple robots that are going to coordinate with each other. So the main, okay, hold on, sorry. Yeah. So the aim of this theme is to basically have multiple robots collaborate with each other and do various operations on the task and place them efficiently. And we have gamified it into a cold storage warehouse environment. So the participants were able to learn from this theme. So they learned about image processing, control system, path planning, and then the inverse kinematics of holonomic drive, and also the robot designing. So these are some of the tools that the participants have been trained with for this theme. So they were trained for MQTT, which is basically standardized communication protocol that is used in IoT. Then we have ROS2. ROS2 is like a middleware used in robotics. It's a very well-known middleware that helps you bridge the gap between software and hardware. And also they were trained, for the initial stages, they were trained in a simulated environment. Gazebo is a ROS compatible simulated environment that is like used mostly for simulation. So yeah, so this is the arena of our theme. So on the left, you can see there is the simulated environment that was given to the participants for the initial rounds, and on the right, the images of our actual arena. So these are some of the board designs that we received from the participants. So this is one design. This is another one, and this is another one. So for the finale, the configuration is going to be as follow. So these three are the bots: Glacio, Crystal, and Frostbite. So this is the docking zone. From that point, the bots will start. The moment a bot moves, the run will be started. And each bot, the participants have done task allocation. So as per their task allocation, each bot will go towards a crate. So we have P1 zone, which is basically pickup zone. So the crates will be placed inside the pickup zones, and there are total 4 pickup zones. So So the crates will be placed in this following manner. So this is P2, this is P3, and this is P4. So after the robots attach the crates towards, attach the bot with the crate, they will move towards the drop zone where they have to basically drop the crates, or they can stack it. It's up to them. We have given them the freedom of deciding how they are going to score. So each drop zone has a color assigned to it. So D1 has red color assigned to it, D2 has green crates, and D3 has blue crates. Okay, so let's watch the theme film of Holo Battalion. Sound. Sound. Can you turn on the sound? Laptop. No. ऐसे ही click करो. These are basically the drop zones that are cold storage. So there will be multiple robots. Here we have used 3 robots, and the 3 robots will collaborate with each other to place the crates in the respective drop zone as per their colors. Yeah, so this is basically what I told. They have learned about image processing and all. Okay. So this is the simulated environment that we gave to the participants for the initial round. And this is the actual footage that we have received from the participants. So that was it. So moving ahead. Okay, so moving ahead towards the scoring parameters. So this is the formula that we are going to use for scoring and evaluating the teams. So this has been provided to you in the sheet, and also in the rule book it has been given to the students. So T is basically the total time, and PC is picking of the crate. So they pick up the crate, then there will be one count for it for each pickup. And for CD is basically the dropping of the crate, and N is the number of stacks that they will be making. There are only two types of stacks that are allowed. So they can either place a crate on crate, which is a valid stack, or they can use 3 crates to build a pyramid type of stacking. And AB is used to calculate the deviation. So we have mentioned 10 degree of deviation. So basically the yaw of the crate has to be 0 or in the multiple of 90s. So apart, if from that 10 degree of deviation is allowed, or if it's more than 10 degree, then they won't get any marks for it. And okay, quality of stack is again, it is derived from A and B parameter. And CP1, CP2 is basically two types of collisions that we have considered. So CP1 is bot-to-bot collision, and CP2 is bot-to-crate collision. MI is the manual intervention. So the only manual intervention is allowed is getting the bot directly back to the docking zone. And RD is basically after placing all the crates, they have to return back to the docking zone. If they don't, then they won't get any numbers for it. And yeah, so bonus point, if they have done everything perfectly, they will get a bonus marks of 100. And a valid run will be considered only if the team places 2 crates. Yeah, so you can use these parameters for asking them the questions and judging their theme run. So bot design, control architecture, and task calculation. They have also done us perception through the centralized system that we have provided to them. And you can also evaluate their stacking. So yeah, so these are the theme developers of Holo Battalion. So Sri Venkateshwar Iyer, Bhavik Jain, and myself. And also special thanks to Jason, Arun, Maddu for doing all the artworks, and the entire e-Yantra team. Yeah. Thank you to the Ministry of Education for providing us the support. Thank you to the founder of e-Yantra, Professor Kavi Arya sir. Thank you to the PI of e-Yantra, Professor Shivram Kalyan Krishnan. Thank you to Nived sir. And thank you to the entire team e-Yantra. Okay, so let's start the show and see the battalions take over the arena.
Okay, cool. So for internal scorers, so I will mention T, PC, CD and all. PC, CD maximum will go up to 13. That is there. And that QS wala we will evaluate afterwards. It's auto evaluator. And collision and all I will just mention CP1 and 2. I guess everything is clear. So this is the team ID 1154 from Vishwakarma Institute of Technology, Pune. 1154 from Vishwakarma Institute of Technology, Pune. So is the arena is ready? Sahil? Yeah, okay, fine. We'll wait for that. So again, I'm asking, is arena is ready, right? Scorers and timers are ready. Participants are ready, right? I didn't send you to run. Sorry for this. We'll reset it. So participants, please wait for my instruction. Then only you have to start the run. Fine. Scorer ready. Uh, arena ready. Everything ready. So yeah, you can start the run. So after bots moves, the timer should start. So in meantime, one participant from the team can say what is happening.
Hello everyone, myself Shreyas, here with my teammates Tejas, Chaitanya and Rohit. We are second year students from Vishwakarma Institute of Technology, Pune.
So here our path generator is not generating the path because our one crate is fluctuating. So when the system will get stabilized, it will generate path. Until now, I will explain what challenges we have faced in this system. Firstly, our arm need to be at a precise location of the crate. So for that, we need to tune the PID extremely at precise. So near goal, our speed is slow. Then again, we face collision challenges. We use finite state machine, but due to that, our two of our boats stuck. So we use path planning and all this stuff. Okay. Okay, now our path planner has generated the path.
So yeah, so just wait. Yeah, so you can start the run. So timer will start after bot moves from the docking zone.
Yes.
Yeah.
Okay.
Timer start.
Okay, sure. So Crystal is moving towards P1 zone. Glacio is moving to pick up the green crate from P1 zone. Manual intervention.
One manual intervention.
Manual intervention.
Two PC.
Or second manual intervention. Okay.
No.
Okay. CP.
One more CB now. Two CD.
So Glacio is following lane.
One CP1.
Actually, this was issue with our path planner. So it randomly allocated the tasks. Actually, there was its offset.
One more
sets.
CP. Huh? Pick up PC. One PC.
Actually, the problem happening here is that just a while ago, before starting, the arena was got disturbed a bit. So our crates are not being detected properly by our our OpenCV.
One
So,
CD.
so that's why the crates are not been stable in our view, and they are moving from here and there. So that's why the bots are getting confused and causing some collisions here.
Okay,
One more
Glacier.
CD.
Actually, here we have put one lane. A crystal always follow this lane. So we have, okay.
One CP2 and one CD. One PC.
Next run. हाँ. Not now.
One CD. One CP2. Timer stop and one RD.
Second run.
So we will have another run. So
We
we
need to
have
make
to
one
just
hardware
place the
change,
box
just
again the
as-
same configuration.
Okay, do it. Okay, just a bit of hardware issue we have here.
So it's a nice setup. So teams are ready. Just wait. I'm just. You can start the run. Timer starts.
Oh,
1 PC, 2 PC. Now total 3 PC has been done till now. One manual intervention and yeah. One more manual intervention. One CD. One more manual intervention. One collision. So CP1 1.
Manual intervention.
CP1 1. And one more manual intervention.
We just picked it and brought it back.
Actually,
That is not
oh, he done this by mistake.
invalid.
One PC. So in the theme there was a rule when you are doing manual intervention, so bot should be placed at the docking zone. But when you have saw that they just took the bot and placed in the arena only, so this will be considered as invalid run. Okay, yeah, thank you. You can end the. Now you can go for the viva session with the judges. So next team 1086.
Good afternoon, sir. Myself, Rohit Santosh Wakde. I am from second year Computer Science Data Science Department from Vishwakarma Institute of Technology.
Good morning. Myself, Tejas Aire. I am also from second year Vishwakarma Institute of Technology, Pune, and I am from ENTC department.
Myself, Chaitanya Yuvraj Kharole, from Vishwakarma Institute of Technology, second year from Electronics and Telecommunication Department.
Myself, Shreyash Sharad Patil. I am from Mechanical Department of Vishwakarma Institute of Technology.
You had some difficulty in detecting colors of the boxes. What do you think was the issue?
Actually, sir, that was a calibration error. Previously, for yesterday's run, it was calibrated properly by us, but today the arena got a bit lighting, and the arena got a little bit unstable today due to some problem. So we tried calibrating it, but time was not enough. We just got 5 minutes before the run. So and we were not able to. We didn't even know that this problem was going to be faced.
I see.
Yeah.
So how do you think we can make this more robust?
So,
What is the kind of defensive programming you could do?
So the
in such
lightning
situation?
we could have enhanced the clahe, which would have been more adaptive to the lightning, and the threshold values could have been a bit less strict, and that can be a bit dynamic by using some algorithms of. Actually, I don't know, but I have read about that a little.
Okay. Secondly, when you move the robot,
Yes.
you know the you have to stack the boxes in a certain orientation. So the pose of the robot
Yes.
is also important because
Yes,
when
right.
you drop this thing, so how did you take that into account when you are doing path planning?
Actually, sir, the angles were already told that if the bot is arriving from this side, then the angle should be this at, for example, 90 at the time of stacking. If it is stacking from directly front, then it should be 0 degree. And for picking up the crate from any orientation, we have implemented like, we have formed a quadrant. So if a bot matches to the nearest quadrant, the bot will go and match it perpendicularly. So the crate will be picked properly.
So you always orient the robot to be perpendicular to.
Yes, sir, for the perfect pickup.
Okay.
So at the time of drop, the orientation will be known to us.
Last question.
Yes.
In this situation, how does holonomic drive help? I know you are moving sideways, you are moving front, so that way you are making use of holonomic drive in your motion. So what's your strategy for planning the path, given that you have holonomic drive available?
So actually, holonomic drive gives us the opportunity to drive directly diagonally to shorten the path. So this is the best opportunity that we get using the holonomic drive. Because if we have four-wheel drive normally, then we will have to go reverse and then we will plan the path. And using the holonomic drive, we are reducing that effort and distance for that.
So you move straight from where you want
Yes.
to go to this,
Yes,
is it?
right.
But there are other robots in the path.
Yes, for that we had implemented the artificial field repulsion.
Okay.
Yes.
Okay. Thank you.
Maybe I'll ask a little bit about your coordination strategy. What was the information that was shared between the robots in order to complete the task?
Actually, this was controlled by a single multi-holonomic node via MQTT. So we have one global planner which planned everything in upfront. So once it detected all the crates in arena, it planned how its boat will go. So during our perception view was fluctuating, so it were randomly adding some crates to the array. So they were not able to generate proper paths. That's why this collision happened. Our strategy was we have made 3 lanes for each boat. Everyone will follow its own lane.
I see.
And then they will come and drop. And for as a fallback mechanism, we have added artificial potential field. We have enforced zone locking, strict zone locking. If one boat go in this zone, no other boat can enter the same zone. So this was our plan.
So you had a global plan, a local obstacle avoidance,
Yes, yes.
and a grid-based one. But then, is there any kind of feedback that's being used while the robots are moving? So so let's say some part of the plan is not executed as you expect. What happens then?
Then the boats will.
Forward way, since you have this, you could have avoided so much collisions that at least would have stopped, right?
Actually, sir, after the semi-final round, which was online, we had been trying to implement a different strategy. In that strategy, the crates were being placed in the middle beside the D1 zone, sorted by crystal, which is the bot in the middle. So the crystal will sort the green crates and blue crates to the D3 side. So the frostbite and glacier will pick up those crates and put there. So there was no doubt that there will be no collision in the bots. But later we found out that if we drop the crates there, it will be counted as a crate drop. So all our efforts were in vain, and it was like silly thing. And when we tried implementing this new algorithm, our batteries got damaged, so we didn't got the chance to develop the new algorithm. So we were continuously developing even we were here.
Okay, maybe one final question in terms of stacking. Did you plan to stack them on top of each other, or?
Yes, sir, we had planned, but our controller didn't work that way.
Actually, our ARM were designed for only stacking. it could stack 1, 2, and 3 layers.
Yeah, I see. It's
Yes.
vertical.
So we have previously used one arm, 2D of arm, and now we have designed this mechanical from my friend from mechanical will explain about it.
Actually, first we have at first we used the rigid links with 2DAF. So now we have used the slider crank mechanism with a flexible link, so that we can stack.
Thank you, ma.
Okay, arena has been set up. Scorers are ready. Timers are ready. Team ID is 1086 Krishna Institute of Engineering and Technology. 1086. Okay. So participants are ready. So yeah, you can start the run. So no, थोड़ा mess हो गया. Okay, you can start.
Good afternoon, judges. We are from Kite University, and
So they are checking their board. Just a minute.
yes, sir. So, good afternoon, judges. We are from Kite University, and my name is Mansi, and my team members are Aryan Tiwari, team captain, Rishi Raj, and Kaniksh Singh.
You can tell what is happening. What is the issue?
So, we need to check the commands.
Okay. So you're starting the script.
Commands are not publication.
Just a minute. Rerun it. So you haven't said us. Rerun it. Start. Yeah, you can start. Timer starts. PC1, PC2, one manual intervention. CD1, CD2, CD3, PC1, PC2, CD1, PC1, CD1. PC1,
So our green crates had
CD1,
some plates.
CD2,
And now
PC1,
bots will move for the red crates.
PC2, CD1,
So our bot crystal returned back to his position.
CD1,
Same goes for frostbite.
PC1,
Oh. And now Glacier is going back to his position.
timer stops, RD1. End of run. So yeah, we will rearrange the arena now. So you can wait.
So we are checking for the year of the grades.
Ionized final. Scorer are ready. Kindly wait. I will just give you instruction to run. Scorers are ready. Timers are ready. Yeah, cool. So you can start the run.
What's on?
Yeah. Timer starts. PC1.
So green crates has been picked.
PC1. CD2. One collision. CP2. One manual intervention. And another CP2. One more manual intervention. CP2, one more. One more manual intervention. One CD. One PC. One more PC. One CD. One PC. One CD. One CD. One manual intervention and end of the run. So yeah, you can go for the viva. You can take. Next team, 1747. Bring the robots, all three.
Hello, sir.
We can start next. Tell about your name.
So we are team 1086. We are from team HB. My name is Aryan. I am from computer science department.
My name is Mansi. I'm from ELC, that is Electrical and Computer Engineering.
And my name is Rishi Raj, and I am also from Electrical and Computer Engineering.
Myself, Kanishk Singh. I am from Electrical and Computer Engineering.
Okay. Okay, ma. Maybe can you compare and contrast between your two rounds? Because something went well in first round, something did not go well in. Maybe what went well, or what was your, if you would have given a second chance or something, what you would have done better?
So we are 100% pretty sure that this bot didn't respond due to hardware issue, because the command was all same. There was a single script running for all the three bots. So there won't be any logical issue behind the script. There is a hardware issue. That's why it was not operating as it should. So
what is the exact hardware you are predicting? What was the problem?
So the hardware issue is totally about the internet, sir. We are getting the commands through MQTT broker. So if there is a internet delay in this, the command won't reach at time, and there is a delay in the steady state error could arise.
In MQTT you have QoS, right? Like QoS 1, 2, like that. You can validate the quality of that and then you can process, right?
Yes, sir, because we did at our hometown or in the college, there was no issue of the internet as such. We are providing internet with our phones, and we have a network issue here. So we were using Wi-Fi at our home places. So, but here it is just phone hotspot.
Have you tried it here before?
Yeah, yesterday we did run. Yes, yesterday it was good, but today it's.
Obviously, I think internet latencies will affect the solution, because that's in, what is the delay.
So because we tried
compared to the requirements of the physical working here.
So all the three bots are completely identical.
True.
There is no hardware issue. If one will face, I'm pretty sure
But
that
they are at different locations.
no perception issue, sir, as such. We made sure about it yesterday as well.
In your first round, you already went back home. That means there was a logic is correct, right?
Yeah.
If in your first round, you did some almost 9 picking correct, and then 10th one you didn't pick it properly.
Because that's what time was over for the run. There is a timer running in the script. We are trying to receive the docking point, so we made sure that if this particular time is reached, make all the bots return to dock. So we get the
even in spite of not picking, that is your logic to get the scores of that.
Yeah.
Okay.
Like you asked for the previous theme, what kind of coordination is going on between the three robots?
So basically, single script is running. These all three robots are being controlled by a distributor. There is a distributor in our script. This distributor decides which crate to give, what is the priority of the crates, and which bot will receive which crate.
At the very beginning. So you do this once and that's
the
it.
distributor is running same with the controller. The controller is running for all the three bots separately, and the distributor is single entity. It's giving commands which pick when that sort of thing. So controller runs for every bot, but distributor guides them all.
Are you one small question in this? Say, for example, your distributor sends a command to your robots.
Yes, sir.
Whether you are sending something back to your distributor?
Yes, sir. We have,
So that means the internet, if it detects, you could say, no, this many bytes I have detected, or some statistic, can you show it in your, like, you should have made some recovery mechanism there.
Sir, our bot, at the beginning there was an issue when we did manual intention, place the bot at the crate, but we have a IR sensor in our bot, which is in the front of the bot. So the crate actually was misplaced by the bot due to the jittering and something. So the last position of the crate was remembered to the bot, and he was trying to pick at the particular pose. He was right at its own point, but the IR is saying
Since
he
you have
cannot
a camera
pick.
feeding every time, no, we would have not used that recovery.
So because of jitterness, the FP, so due to the
correct, ma, I understand.
Yeah,
There is a
the
jitterness
maybe crate sometime detected, and that will make the bot to go, and then suddenly there is no crate there, so it will go back, and this sort of
Since you
thing.
have a live feeding on top,
Yeah.
everything is coordinated, everything is referenced. So how frequently you do a path planning, or how you do generate, or it is only one time?
So path planning.
No, say for example, there is a crate, the robot has to
Yeah.
move towards the crate and pick it up. So there is a coordinate system on the robot and there is a coordinate system on the crate. So how much time you calculate this?
So it's 20 hertz for us.
20 hertz means
Yeah.
it should work,
It's-
right?
So the commands are being sent to the bot, and all the calculation are calculated in about 20 hertz, which means in a second it's 20 times.
Understood, understood. That I got it.
Yeah.
That means that correction has to faster be, right?
Yeah, we tried with multiple hertz, but this one suited.
Correct. 20 hertz is very much sufficient, I'm
Yeah,
saying.
20 hertz is very sufficient. And all the calculation are being done. We are using DWA, dynamic window approach, to localize localization in local. Yeah.
DWA is for avoiding obstacles.
Yeah, that's why our bot was not colliding with each other. There was.
It collided with the blocks.
Yeah, it collided with the blocks due to jitterness of the crate. When the bot come near the crate marker, or due to the hand of the bot, gets lost by the vision. So that is the issue.
Okay, it's the occlusion issue.
Yes, sir.
How did you divide work between the robots? I mean, which block should go to which?
So we have divided the bots as per the pickup zones. In the first round, you have noticed one bot returned to the dock very initially, because P4 and P3 didn't had any crates. One bot is assigned two pickup zones. So to avoid clusterness near the pickup zones.
At the beginning.
Yeah.
Because
It's
at the
priority.
end there were several crates left.
Yeah.
And two bots had gone to
Because
the
of the timer, sir.
homing position, and the rest of the work was left for one robot to do.
So because of the timer. And that work was. Huh? So that bot was not responding, and that other bot was about 1,000 meters away, 1,000 millimeters.
So work planning you don't do dynamically, right? You
Yeah,
do right in the
within-
beginning.
right in the beginning.
Similarly, path planning also you do statically at the beginning?
We have a DWA, so it calculates where it have to go. It just have a goal. It's reactive.
Yeah.
A local path planner.
Okay.
So that's why there is a computation load as well. It might be an issue in our case.
Okay.
I think we are out of time, I guess.
Okay. Thank you, sir.
Thanks.
Thank you, sir.
Teams are ready. Teams are ready, right? So yeah, just a sec. So team ID 4. Okay, sir. Team ID 1747, St. Francis Institute of Technology. Team ID 1747. Scorers and timers are ready. Yeah. Team is ready. Yeah, you can start the run. Timer starts. one PC, one manual intervention, one more PC, one CD, one more CD, one PC, one PC, one CD, one more CD, and one PC, two PC, one CD, one more CD, and again one more CD. So that is a good stack. One PC, one return to dock, one RD, one more RD, one CD. One PC, one CD, one RD. End of run. No bonus.
Good afternoon, judges and all the friends over here. We are from St. Francis Institute of Technology, Mumbai, pursuing electronics and telecommunication engineering. Myself, Unnati Manya, from third year. He is our team leader, Marmik Parmar, third year. Aditya Bhole, second year. And Arpita Gavde, second year. At the start of the run, you might have noticed that the bots have not yet started moving. So it was not a technical issue. It was just a 10-second delay, which was given for safety purpose.
Okay, check the configuration once. Is it correct, right? Teams are ready? Okay. चल रहा है संभव होगा एक एक रन निकल सकता हूँ क्या हुआ सो डुप्लीकेट केस डुप्लीकेट केस आए सो बाकी दो डुप्लीकेट सो दो फ्रेज जो सेम आईडी पर वो ऐसा उनका और हमारा क्रेट मिक्सचर या वी आर डिस्कसिंग दैट वेट
either you do one thing, you keep the run all the runs coming same run.
The point is that we are under trading. No, keep it same but we are saying duplicate है ना तीन वो सामान्य है उसकी लिस्ट में तो रिपीटेड आ गया तीन पैर आ गए ये अपना नहीं वही ये किसी ने चेंज करा ये अपना है ही नहीं किसने चेंज किया भाई
हाँ वही अरीना में था
चल क्या रहा है
देखने जीरा
ये सही है
I think you keep it same for everything. Let it be like that. But it happened. अभी भी they are keeping it because of that awareness.
Somehow it came.
Somehow it's duplicate kits. Somehow it was duplicate kits.
Okay, these things happen.
Now it came. Now
So
what
I
do
will
you
suggest you
For everyone you cannot do that. You don't have time.
what to do with that.
Okay, for these teams, you keep non-duplicate whatever you have in a configuration system, and then from next team onwards, after the team ends, you will do it.
Okay, so
But you have to do it first.
but we'll say for this one run we'll do afterwards we'll do again. So कहाँ करेंगे?
लंच के टाइम में करना पड़ेगा. फिर अभी क्या यही क्रिएट करना है.
तो अभी जो रन होगा उसमें हम लोग सब आइडेंटिटी क्रेट डिफरेंट क्रेट ले लेंगे इसके बाद ड्यूरिंग लंच कितना
So that it will be fair for everyone.
फेयर फॉर एवरीवन ठीक है
मतलब सबको मिलेगा ना.
किसी को no everyone would get this.
सबको मिलेगा
अभी अपन ने बिल्कुल पर एक्सेप्ट कर दिया.
So you check again once what is the step.
Is it according to the configuration, the numbers, placement and everything?
Color is only the configuration
But in the rule book have you mentioned what Ruko IDs can repeat or cannot repeat?
हाँ तो प्रॉब्लम क्या है रिपीट होने पे इशू क्या है वी डोंट नीड टू रन एक्स्ट्रा
Venki,
वेंकी इधर आ वेंकी
mentioned key can't be repeated or something. What is the problem in repeating? It's not in the rule book, it's not in the
and then what is the problem
Yes, he only saying duplicate होगा and
तो we didn't specify there won't be duplicate
I think we should go with the same.
हाँ
he said this to us.
that
Because that is fine.
unless we specify there won't be any duplicates we can run with it
Show him the rule because
from our side it's defined कि अगर ये जो नंबर है ये divided by 3 वो रेगुलेट है
reminder
this is the only thing it's not mentioned कि repeated
So, judges, kindly wait for some minutes while I'm discussing. So, yeah, sorry for the.
how would someone create a list of this box is like एक ID आ गई लिस्ट में डाल देगा
Let's continue with that.
जो पहला वाला आईडी उठा है पोजीशन उठा है
Okay, cool. So what exactly happened here was like we had same IDs ka crates here, same IDs ka 2 crates in the same color. So the team was saying since it's identical we can't able to pick up. But as we discussed with our leads and all, and we reviewed our rule book. So what was that key? Like we are going to continue with that because as per rule book it has been mentioned that crate ID is only for bifurcating the colors. Even though if you are identical IDs, if you have a formula, it can tell that 2 red crates are there. So logically, we discussed with our leads. So they said you should proceed with this configuration only. So initially we said we might give you another run, but again we discussed with our eYRC lead. So they said better we go with this configuration only. So according to logic, what is that key? Like you, it's create ARCO ID, the end given for creating. but rule book में हम लोग mention नहीं किया ना create.
Let's not discuss right now.
So we will continue this run and we will discuss this afterwards. Same crates, every configuration, same configuration.
It will be same as what the first and the second team have. We'll keep it the same because nothing related to this was mentioned in the rule book. So the logic should have been actually the logic is there is no point in arguing right now. Let's continue with the
Let's complete this.
If there is any argument, we can take it up. I'm just saying that we'll get response. I understood. Let's take it after the
Scorers are ready. Team, ready. You can start the run. Teams are ready. So yeah, you can start the run.
Ten seconds, guys.
Timer starts. Two PC. One PC. Two CD. One CD. One PC. One PC. One CD. One more CD. One PC. One more PC. Three CD. Three CD. One CP2. One PC. One more PC. One CD. One more CD. Three RD. So yeah, you can go for the viva.
Quick announcement, crop drop team members, finalists who are there, please go and have lunch because your team will start at 2, so you need to have lunch and be prepared. And to the
ये बोलेगा ना कि अगर वो वाला
HV team members and all, when you are in the arena, try to be civil, don't be get angry or anything. Okay.
So hello, my name is Marmik Parmar. I am in third year EXTC.
Okay. So, okay, yeah. Nice work. So in the second round, at least we saw lots of stacks, lots of crates being dropped. So very nice to see that. Again, I guess maybe I'm a little bit more towards the coordination. So what kind of coordination strategy did you use in this to distribute the workload?
Yeah. Hello. So the task assignment was predictive auction based. So there were criteria such as distance between drop to pick to drop, which was not initialized in the greedy system. Greedy algorithm just takes nearest path. But this one also calculates the drop path. So it takes the optimum solution and delivers the shortest path. There are also many criteria such as same color crates would not be picked from the same picking pickup zone. And then again, there were like same pickup zone also has penalties. So the bots will like forced to go to the different pickup zones so that there will be less chance of collisions and all. And as you see that our bots in the first run didn't pick 3 crates, and in the second run also 3 crates, because in our code we have the system system dynamic. So once the crate is initialized and assigned to the bot that it has to deliver it. So in its case it delivered, so it gives the check that it is delivered. But then if there's duplicate, then we can't help, because it's not like 16 into 2, like 2 crates of 16 ID. So it's not 16 into 2. It's just 16 assigned to bot. And our code was dynamic in that way.
Yeah. Okay, so maybe just one follow-up before I give to the others. So, you mentioned there's some objective of minimizing the path with some constraints. It's kind of a constraint optimization problem, right? So what kind of methods did you use to solve this?
So like he mentioned the allotment. After that we had a theta star, like which is a modified version of A star for path planning. The path planning was only relevant until what the bot goes from to the crate, like what path it takes and what inflation radius, like what avoidance it takes. But then after that, it was wholly dependent on the local planner, which is adaptive potential fields. So like the benefit of adaptive potential fields was that it balances repulsion and attraction. So what happens is, like you can see our collision avoidance was pretty good, like it never crashed into any crates and never crashed into any bots. So like that's a major advantage of using adaptive potential fields over potential field or any other reactive control.
Yes. I said last question, sir.
Okay. So nice one. So the effort was really good, and what was the difference between your A star to theta star? What made you to move to that planning? Maybe that was, I thought what is your planning was the question you answered previously.
Yeah.
It was what made you to move from A star to theta star?
So we actually never implemented A star because the system is holonomic. So why use 45-degree turns and 90-degree turns when we can use free motion? So theta star provides us the most optimum path in this case.
How did you discover this? Like what was your comparison parameter you used to say? Maybe I wanted to ask you about the collision parameter, or what is the collision algorithm you have been using, and what made you to select that? Similarly, path planning, and what made you to select that? What are the comparison you have taken for consideration into that?
So initially we used to do only the APF and not the global planner. We didn't have global planner. But then we understood the importance of it when the number of crates is more. So there will be cross pathing and all. So even this is penalized in the theta star, that if the cross path is there, then it will take a longer route detour. So global planner does only the planning part, and the collision, it doesn't measure collision avoidance or anything. Collision avoidance is purely based on APF, matlab, APF. Then we have also used nudge, but initially it was like nudge was just opposite to each other. But then what we implemented was then nudge will be in the opposite side and towards the goal. So this helps by giving the force, giving the side to the goal, and like reducing the distance. And also that nudge should not happen when it is near a crate, because it can collide with the crate in that nudge, because it doesn't see that it's crate or not. So we have kept the radius of the crates, and then nudge won't happen in the, as you saw in the first, where we nearly, like we narrowly did the collision avoidance.
Thank you, ma. Nice. Good attempt.
Yes, I think your second run performed quite well.
Yeah.
But at the end, 2 robots were waiting while there were quite a few crates left, and third robot was left to do the work.
No, that as I mentioned, that because
of that
crates were duplicate, ID were duplicate.
Otherwise, you have a dynamic planner.
Yeah.
I
So
see.
if you keep 13 crates or 20 crates, we don't matter. It will all be assigned equally. So it is. Yeah, we need. Yeah.
Now there are some duplicate Akumas.
Yeah.
It is actually dependent on the ID. So the ID calculates the color of the crate. So using that assumption, we were assuming that we'll get unique IDs for different.
So you don't do color detection at all from the image?
Yeah.
We do. The formula is given that ID remainder is 0 to red, remainder 1 to green, then 2 to blue. Then it assigns the drop zones. So it can be done like, we haven't a system where if the crates are duplicate, then it is multiplied by 2 and assigned to other. And also because all the other tasks had the different crate IDs. So it's a basic assumption that we have to make the system dynamic and ready for all approach. But of course not the duplicate crates.
Okay, one question. Your arm has 2 degrees of freedom.
Yeah.
Why do you need that?
So initially we thought that the stack can be of triple stack. So our dimensions of arm are like that, and we kept it simple, like not a pulley mechanism or anything, because this way it's simple to pick and place, because it won't be like if there's height issue, like it was in the practice run where the crate's height was 5.5. So it won't matter to us, but in some cases it will matter.
So what use do you make of this angle control?
This one?
Yeah.
So when we have to keep for stack, the angle won't be same as keeping for bottom base crates. So I can.
You just have to drop perpendicularly. The second arm can always be perpendicularly down. Yeah.
You drop it for base, it will be touching or it won't be accurate. But if you're facing it for stack, it will be better, because this is not better even. See, you can see the angle at which the crate will be placed.
Okay,
So,
I see.
So if you put it like this, it will be a soft motion and the crate will stay.
Yeah.
So if we keep it like this, then it will be like landing on the edge.
It also gives us freedom to hold.
So can you let the gravity orient it perpendicularly down?
For that, it gives us the freedom to hold the crate as we want. So like if we hold it like this, then what it will give us is like it will give us shorter radius for the crate, like when it's holding. So like we can tune it to our system. So like we can hold the crate like this if we want. It will make our radius like as short as the bot's radius.
Did you ever do that?
We tried, but it was
I didn't see that happen.
solenoid wasn't strong enough for that. So like.
And one more reason was that the weight balance won't be good in that method.
Okay, thank you. At least you thought that out.
Nice, ma. Good attempt.
Yeah, very nice.
So next team ID is 4822, Indian Institute of Technology, Hyderabad. Is the team is ready? Scorers and Timers. Okay. So yeah, team, you can start the run. Timer start. One PC. One PC. One more PC. One CD. One more CD. One PC. Two PC. One CD. One PC. One CP1. One CD. One more CD. One more CD. One PC. One CD. One CP2. Timer stop. 3 RD.
So scorers are ready, timers, participants are ready. Participants ready? So you can start the run. Timer starts.
Hello, hello judges. My name is Rupansh. I'm the team leader, and this is my teammate Pratik, Shaurya, and Mohan. We are from Indian Institute of Technology, Hyderabad, and this is the first time we are participating in e-Yantra. And yeah.
2 PC. One CD. Yeah, in meantime you can explain what is happening.
So basically, when two bots are very close, their path is already pre-planned. So there's a waiting time for one of the bots' path. So it just waits for the
One CD.
other bot to go away. Yeah.
One PC. One PC. One CD. One more PC. One CD. CP1. One manual intervention. One CD. One PC. One CD. One PC. One more PC. One CD. One more CD. Two CDs. End of time 2 RD. For the viva. So next team 1404 from Sanjeevani College of Engineering.
problem is solved.
Yes, sir. Basically, hello, sir. My name is Rupansh. I'm from IIT Hyderabad, and
I'm Shaurya. I'm also from IIT Hyderabad, second year mechanical department.
I'm Pratik. I'm from IIT Hyderabad, AI department.
I'm Mohan from IIT Hyderabad, from Mechanical Engineering Department.
So what is this rubber band doing here?
Actually, the torque was too high, so it was like if we didn't use the rubber band, the arm couldn't hold the load of the arm, so we had to use the rubber band to balance it, counterbalance it. Yeah.
It's a spring counterbalance.
Okay. Yeah. No, it's nice. Yeah. The slack in the thread, this thing you take up by the rubber band pull. Yeah. All right. Okay. I have really only one question. You can explain a little bit your work allocation algorithm. Is it static? Is it dynamic? Your path planning, is it static? Is it dynamic?
So basically, we are using A star with basically in A star. First, we assign the bots to the crates, and then using greedy allocation. So we basically compute the shortest distance and then assign them to the crates. And then once they are assigned, we know their locations. Now we run the A star algorithm. And for each time, basically we discretize the whole map into boxes, graph. So each box, if it moves, it's considered as one time step. So that's how we added time to the path planning. So and we defined what the time step unit will be. In our case, it was 0.75 seconds. So for every 0.75 seconds, it moves from one block to the another block. And that's how we discretized, added time to the path planning. And basically, so after one bot is done, then the other bot will consider basically will reserve all the vertices of the previous bots and all the edges of the previous bot, and then the other bot will consider those into accommodation and then path its plan accordingly. So it will never overlap. So that's how we do it.
In terms of cascading the A star between bots. Okay. Many of your pickups did not succeed. One reason I saw was that the magnet was not perpendicular to the crate. It was tilted. Okay, that is one problem. So what would be the solution to that? And secondly, if such events happen, how do you think you can harden your solution? Can you add some sort of fault tolerance?
So basically, our crates weren't being picked up because of that reason, and one more reason was that the yaw was fluctuating a lot. So bot was assuming that the crate was here, and when it went down, but the crate is a little bit side, so it doesn't pick up the crate. So the yaw was we focused mainly on the yaw. It was the biggest issue. So
I guess a little bit also the design of the arm itself. I think you probably made it hard for yourself to pick up with that design. Okay, maybe I'll ask a little bit about collision avoidance. Was there any collision avoidance, or it was just assumed through planning that you would avoid?
Yeah, I told you, sir. Basically, when the bot drops in a certain drop zone, we reserve that drop zone for 15 time steps. So that
this is at the very beginning when you're doing the planning, right? So there's no recalculation happening every time step, or it's happening every time step?
No.
Just once?
Just once.
So then you're basically assuming that whatever you planned is executed as it is without any error.
Yes.
Right? So this is a real world robot. It will never follow, even on an arena, exactly what you expect, right?
I mean, sir, we only faced issue when the bots were very close to the drop zone. So we added the time steps to avoid it. And after that, there were very less. Actually, there were no collisions. It happened just today, and it didn't happen yesterday. So.
I mean, typically what one does is to have, what other teams have also I've seen done, is to have some kind of a reactive mechanism that you move away if you see something using your local sensing. On a simulator, this will work perfectly because you have completely seen the future and you do it. But yeah, this is robotics, so I guess welcome to the robotics.
Maybe the one simple question was like, I think both it's a right combination, like 2 mechanical and 2 software guys are there into this team, so it's a very good right mix. But the handshaking would have been better. The execution would have been much better. Say there were some like the arm gripping, we were not able to get the perfect contact. So if you would have done that, you would have made a good scores as per the tally. That is one point. So how could let us say this is the problem with the mechanical, or say how as a software guys you would have solved this in a better way? Say because everywhere we cannot expect the 100% perfection, even in life or everywhere, wherever you find a partner, you have to go hand in hand with the partner. So say you found there is a gap. I think this robot is with you for more than 3 months, or at least 2.5 months to 3 months with you. So what as a software you would have taken these things? One thing, you would have scolded them, or you would have taken the control as a leader, you would have made them to change the design. Or some strategy you would have followed in the software. What would have been maybe?
I mean, if there was no time constraint, then I think we would just use another, like again, we'll just check on another frame where the crates will be detected, and then again replan them.
Even every time before you pick, if you would have acknowledged that pickup, since you have everything feedback, correct? You have a marker, you have everything feedback. Once you check back again, that would have been easy, right? You are always, your loop is like, whether you pick up or drop, you are going and dropping. So if you calculated the time in a little more wise way, you would have solved the logic. So thing is, you are at second year. It's good that you came here and doing this things. Say always the right mix works well, but someone should extend an extended hand to pull the others out. Thanks. Sure. Yes. This show that your coordination is much more stronger.
Sure.
So you have 2 more years to left with you. So
Thank you.
So next team ID is 1404 from Sanjeevani College of Engineering. Scorers and timers are ready. Participants ready. So you can start the run.
Good afternoon, everyone. So we are
Timer starts.
we are from Sanjeevani College of Engineering. So our team leader is Sai. The Vishal team members are Vishal, me, Bhakti, and Shantanu. So I would first like to thank my college faculty and directors to provide to help us throughout this competition. So now
2 PC and one CP2, one CP1, and one manual intervention. Again, one more CP1, one more manual intervention. One more manual. It should be in one more manual intervention. One CD.
So here we see that black robot has been stopped. So the reason is
One more CP1. So, sorry, one more CP2. One more manual intervention. One more CP2. One more manual intervention and one PC. one more CP2, one CD, CP2, one more manual intervention. So end of, no. Proceed. You don't have any manual intervention. Uh, Scorer one PC, CP2, CP2 again, one PC, one CP2, CP1. Done. End of run. Only one RD. Oh, that was kept manually. No RD, no RD. Scorer are ready. Score and team ready. Yeah, you can start the run. Timer starts. One manual intervention. One PC. Two PC. CP1, no? CP1. one CD, one manual intervention, and one CD. CP2, two PC, one CD, one more CD, CP2, CP2 again, three CP2, CP2 again, one manual intervention, CP2, manual intervention, end of run, time stop, end of run. So next team is team ID 1832 from Atharva College of Engineering. So this is the team which did good. It's an all-girls team. This team did good performance. They are topmost all-girls team present. So we called them to show one run. So there is no required of internal scoring for this team.
Hello.
What didn't get?
Hello.
Good afternoon, sir. My name is Shantanu Duryodhan.
I am Vishal Vargad. I am from TY Mechatronics from Sanjivani College of Engineering.
I am Bhakti Bairat from TY Mechatronics from Sanjivani College of Engineering.
Hello sir, my name is Sai Lokhande. I am from TY Mechatronics from Sanjivani College of Engineering.
So why were there so many collisions?
Actually sir, there was different types of two same color, same ID marker. Actually we have not put the code for that. and therefore the robot was going to pick up the same marker there. Therefore, the collision was happening.
But you have IR proximity sensors, no, on the bot. You can know what is around you.
No, we have not used the IR sensor in our bot.
Okay, but you could have used it.
Yes, we.
Okay, fine. What is your control was also coordination strategy? No, that I'll leave to you.
Yeah, yeah. So, what was the coordination strategy you
So,
used?
This is basically a grid-based. So means we have used A star at first, but our robot get deadlocked at the point, so we haven't able to properly calibrate that. After that, we switched to grid-based strategy, and for that we stop one robot on the priority based. Means if one robot has a carrots in its hands and it is near about the carrots position, or then that robot has a priority to get at the zone or drop that carrot at first, and other robot will wait for that. So we use that.
Yes, I mean the A star is for just point A to point B plan, which in a holonomic case you could just go in straight lines, right? So there isn't much A star needed.
Yes, sir, but we does not able to calibrate that properly, so we have to switch at
I guess the other thing with your grid-based system is, yeah, you'll probably have grids that are perpendicular to each other. So then all these are holonomics, you can really go any place around, so the path is not really blocked per se. It might have to take a detour. So let's say I was going straight, it can take a detour and go to its position, right? Not just stay there and do nothing. Right? So you'll probably gain something. Yeah, I guess that's one comment. The other one was, yeah, on the path planning bit, of course, you said that you do A star and so on. The pinion mechanism was good, so I think. Okay.
We have given the waypoint to the robot, and my robot was following the waypoint.
Yeah, I mean, path planning means how you go there, you then convert it into waypoints and you achieve your waypoints. Right? So that's what I mean by path planning. The one thing that I saw is all the robots were continuously running into the blocks. So was there no mechanism to stop this from happening? Like even when they're in the pickup zone, they're always kind of pushing the blocks around.
Because of same crates, they confuse where it have to go.
I mean, how many same crates are there? There are probably 2 same crates, right? All of them were being pushed around.
3 zones for 3 bots, but that same crates in three zones. Because of that, our bot confused where it have to go.
I see. Okay, I thought it was more of a lower level control issue.
So actually now it is in real time. So if we change the position of the carrot, my bot tries to pick the carrot. And actually what was happening, one blue carrot was first pick up of 16 number ID, and same carrot was here. So it was considering that the carrot has already placed. So it was pushing the carrot, and due to that the red carrot was also moving front. And my robot was continuously moving for the red carrot in real time coordinates to match it.
I guess the lesson is that you need to be a bit more robust to unexpected things, right? Like maybe the number being the same, for example.
Okay, basically, maybe I think most of the questions were covered. The thing is, maybe you could have implemented a bit more good collision mechanisms, because there were penalty points were applicable. So you have everything is vision is visible. Everything is known to you. So you would have taken, say, what was your collision mechanism plan and what did not went well here?
Actually, what we have done is we have given the priority to the robots. Okay, suppose one robot has the carrot in its arm, so it has priority to drop it in the zone. But what the issue we have is that 2 robots with same priority is coming near to each other and waiting for both.
Okay.
So that our
maybe you would have done some trials yesterday, no, with the same different logics.
Actually, we was in the college department. Our camera was little bit high, so little issues have happened therefore.
It's because that perception file was our main trials are being at 8.5 meters in our campus, and from when we reach over here, it was 8 meter.
8
so,
feet.
Yeah, 8 feet. Sorry.
Okay.
So our perception file is trained for that one at first. So
Okay.
we just have to calibrate it.
Is this
when we
your
come
mistake
in.
or data? Data had been given common for all the teams, no? Say,
Yes, sir.
see,
but-
these things, like, you should be prepared for the worst thing when you come for competition like this. So where, when you say, you should have this, all this as a parameter file where you just change it and then it has to work on that way. So that is where the robust coding comes in. Okay. Thanks for your effort. Hope you are in second and third year, right?
Yeah, third year.
So hope you have one more year to witness it. Try to participate, don't leave this session. So.
So there is a team, team ID is 1832. So this team is an all-girls team. They perform well till task 6, but due to high competition, they can't able to come to as a finalist. So we called them and we said them, you can showcase your run, one run. So they can tell you their experience and all stuff. Yeah, you can start.
A very good afternoon, all of you. My team ID is 1832. My name is Kashisha Jagbandhu Padi, and my team members are Nidhi Pal and Sia Kokam. Our journey of eYantra was a roller coaster for us. At the starting, we didn't know anything about it, but one by one, we started learning about it. So, yeah.
So it will be good if you say what all challenges you faced and how you overcome that and what you learned and all stuff.
Mostly the challenges we faced for using the motors and PID tuning, and the most challenging one was the collision avoidance, and I think we still haven't recovered it yet, but
Like you know what, why the behavior is like, keep it and keep that. Fine. So yeah, I guess we can end the run. Cool. So you have any questions for me? Yeah, fine. Oh, thank you. Thank you, judges, for the patience and timing. Give them the round of applause. Yeah. Thank you. Yeah.
Thanks for coming here and thanks for helping us in the judging of the entire competition. Your feedback has been really, really valuable, and your time has been well spent, I assuming, giving more feedbacks to eYantra. We expect you to come back again to be part of eYantra's competitions as well. So as a token of appreciation, we give you this. Thank you so much.
That's heavy.
Yeah. Thank you.